All right, Unit 3, Lesson 1. Let's practice with some fraction reduction here. Remember our divisibility rules. If the last digit is even, it's divisible by 2. If you sum the digits and divide by 3 and it comes out to a whole number, then it's divisible by 3. Divisible by 3, and then if the last digit is a 5 or a 0, it's divisible by 5. Divisible as in you get a whole number when you divide it by. So 24 and 36 are both even numbers, so you can divide by 2. So that gives you 12 over 18. They're still even. You divide by 2. You get 6 over 9. And 6 is divisible by 3, and 9 is divisible by 3. So you get 2 over 3. Now, I could have, way back here, if you remember, if you notice that these were multiples of 12, there's no divisibility rule for that, but 24 is 2 times 12, and 36 is 3 times 12. So you can go straight there. You can divide by 4. Any of these things, as long as you end up with 2 over 3, okay? Let's see, negative over negative is a positive, and that we just found out was 2 over 3, right? A double negative is a positive fraction. Negative divided by negative is a positive fraction. It's important, so remember that. All right, the same thing over the same thing, sign and all, is a positive one. Let's see, this one, a negative divided into it, so the answer is going to be negative. In fact, the answer to this one's going to be negative, and the answer to this one's going to be negative. It doesn't matter if the negative is on the bottom, the top, or on the side. As long as you just have one negative, you end up with a negative answer. If you have 2 negatives, you end up with a positive. Excuse me. And let's see. 32 actually goes into 64. It actually goes in 32 times, but maybe you notice that 8 goes into them. So pick something. You can, if you don't recognize anything, start with a 2 and work your way to something you recognize. But an 8 into 64 is 8. 8 into 64 is 4. 4 into 8 goes twice. Okay. These are both ending in a 5. Let's just start there. They end in a 5 or a 0. They're divisible by 5. 5 into 15 goes 3 times. I already have the negative right here. 5 into 125 goes 25 times. 49. The only thing that goes with 49 is a 7. So 7 times 7. So divided by 7 is 7. And then 56 divided by 7 is 8. Okay, that's helpful if you know your multiplication tables. If you don't, it's going to take you a minute to figure out how to do that, because I don't have a divisibility rule for 7. Okay, so if 2 doesn't go in, 3 doesn't go in, 5 doesn't go in, and you don't know your factors, your multiplication table, you're going to have to try 7 anyway. 7, 11, and 13. Try to see if the number goes into that. All right. Now, we're going to move over here to number 2. It says evaluate integers. Integers are whole numbers. They're kind of what you see on a number line. That's an integer, that's an integer, that's an integer, also that's an integer, that's an integer. So you could say negative and positive whole numbers including 0, but by definition these are the whole numbers. These are not called whole numbers, but that's how we kind of refer them. But integers are, I remember integers as the numbers on a number line. They're where the dashes are. So evaluate means the same thing as kind of simplify. So this is a -1 minus 1, or a -1 plus a -1 equals a -2. Okay, put these in your calculator. Put them as they'd say. 1 minus 2 is -1. This equals 0. Negative times a negative is a positive 10. 5 times a negative 1 is a negative 5. 5 minus 5 is 0. These are in here because you need to be nimble to shift from adding and subtracting to multiplying, right? If this had been, this is weird looking. What if this had been negative 1, with the parentheses? That would have been times, and you would have had a positive 1. But just sitting there like that, that's the same as negative 1 plus a negative 1, which is a bigger negative, okay? Since multiplication operations can be represented by a dot, an X, or just parentheses, okay? Which expression involves multiplication? I can't tell because I drew it all over it. Let me go back up here. All right, so multiplication is just what? D and E, okay? Multiplying fractions. Hopefully by now you're doing something like this. 1, we multiply across the top. 5 times 1 is 5. 4 times 1 is 4. Don't need to reduce that. Put this over this. This is negative 6 over 2 times 2 is negative 12 over 5. This is 18 over 9 or 2. Some people do this and go, okay, that's 1 times 2. That's it, and that's, you still get the 2. Okay, whichever way you want to do that. Don't have a divisibility rule for 9. Just give it a try, okay? 7, 9, 11, 13. Give them a try. Excuse me. Order of operations. This squared means I have 2 of these. Across the top is a 4, positive 4, negative times negative, positive, and 36. 4 does go into 36. This is divisible by 4. This is divisible by 4, which is 1 over 9. Okay. Excuse me. Order of operations, negative 2 plus a 5 is a 3 squared, which is a 3 times 3, which is a 9. Order of operations, say do the exponents first. So a 3 times a 3 is a 9. And this is a 2 times a 2, which is a 4. So this is 36. I like to use what's called the expanded form. That way I don't mess up my multiplication, especially when it's a fraction. So 2 times 2 times 2 is 8. This is 9 times 3 is 27. Okay, another way to write that would be to do it that way, all right? And remember, this is 2 times 2 times 2, not 2 times 3. So put it in your calculator. 2 raised to the power. Some of you need to use the little, this thing. It's going to kind of look like that. Give that a try to make sure you know how to use your calculator for these. Let's see, the top, this here, is negative 6. This here is 14. They're both divisible by 2. Negative 3 over 7. This is going to turn into negative 8 over negative 6. Reduce the fraction. Negative over negative is a positive. Divide by 2 is a 4 over 3. To the third, which is 4 to the 3, 3 to the 3, 4 to the third power. 4 times 4 is 16, times 4 is 64. 3 times 3 is 9, times 3 is 27. Yeah, I think that's wrong on the key. Get my pencil. Sorry, just fixing my key here. On the key, I did the classic example of forgetting what I was doing. I got all the way to 4 over 3 and left it that way and forgot to cube it. In other words, 4 times 4 times 4. So 64 over 27. All right, moving on. All right, so we're going to use a whole lot of exponents now. So this right here, this is 5 to the 3rd power. The 5 is called the base. The 3 is called the exponent. An expanded form. If your homework just says, give me the expanded form, I want you to do that and stop. Don't tell them what that equals when they want the expanded form. If they want you to evaluate it, it'd be nice if you showed the work and then you said that that was 125. Okay? An expanded form. Oops, hang on. Is that evaluating it is what? This is 8 times 16 times 7 is 896. The 7 appears to not have an exponent, but remember, if you don't see something, it's a 1. So that's a 1. Excuse me. Some things in algebra, remember, if you have an x, you know there's a 1 in front, right? Now I'm telling you that there's also a 1 up here that you don't see, and if it was a whole number, there's a 1 here that you don't see. That's the same thing as an x, okay? That's the same thing as a 7. It'd be weird to put the 1 in front, but there's a 1 here and there's a 1 here, okay? Not 0. 7 to the 0 power is going to be something else, and we're going to talk about that, but it's actually 7 to the 0 power is a 1. It's not a 7. 7 to the 1 is a 7, okay? 7 to the 2 is a 49, and so forth. In 92, you're going to get to 7.5, which is the square root of 7, but that's something else. We're not going to do it in this class, okay? That's the warm-up.